No. You never that much, right? Never got that much.
From Yishun is not. Industrial also not off.
Just never meet them. I don't know if they are.
I feel it's your senior. I roughly still can call this name, but I didn't teach them. So, Google. BSCS 2073. Oh, you see, they have repeated that now. Okay. Software fundamental, software chapter 2. Yes. Yours is PDF or? Oh, sorry. The here? Oh my god. Luckily got. See. Hey, where's the no the student huh? The way. Finally, I find my history. Okay, so please join to the quiz here. I'm waiting for other side. Okay, 10% only. Can I start? I'm not so sure. 630261. Okay, use your handphone, tab, whatever. Okay. Just join this one. I thought I had accidentally deleted my quiz. So luckily can be found back. Okay, so please access to the URL there and then type in the code to join the quiz.
Oh, so you can show the QR.
Yes,
Show the QR.
show the
QR code.
oh, 10 months. Okay. Okay. We can scan the QR code. So all got already, oh? It's better. Scan. Okay, so I have to close this one. Okay, so how many? 2, 4, 6, 8, 10, 11 should be 11 students. Yeah. Still got 3 students. 8. Still have 2 students. Yes. Who haven't joined yet? Still need one. Still got 1 student. Hey, wait, to talk this thing now. I cannot issue one. Okay. Okay, I guess we need to start already.
Oh, sir, they're coming.
Okay.
哎呀，
Okay, faster. Yeah, join to this please. Yeah.
我们在这里
边边这边的吗？
看小时。
那么远呢？
有这一张，电视哦。
Okay, this time join faster because we need to start our. After this, we still need to continue with the lecture faster. Yes.
So you just keep on.
Huh? Hey, why all what?
waking me up.
Why?
I don't know. Just suddenly I get it already.
You try again. Okay, so it's ABC and SM.
Why SM 啊？
Haven't find it out. Only one question. Okay, so let us have a look on the question, yeah? Okay, question 1. Yesterday, Monday, okay, we have discussed the first chapter, which is the software architecture. So, software architecture or architectural design is the first phase of the software design. Why? Because normally when we want to create a software from a sketch, okay, so normally we need to we always follow we start with the very high level first. What do I mean by very high level? High level in design means that we start with the overall picture of our software. Understand? Okay? Overall picture of our software. So this so-called overall picture actually is the software architecture in which, okay, it shows the system structure. Okay, I use the word system structure, or maybe we can say that it shows that this system is made up of what kind of item and component. Understand? Okay, so therefore, this so-called software architecture is the initial blueprint or plan that used to show the software system structure. Okay, so why I'm so concerned on using the word structure? Later in the future chapter you will know about that. So in this case, why we need to have an initial initial picture or initial diagram to show the software system? Because first thing is, okay, we try to avoid any ambiguous, as different people may have a different thinking or different expectation on the system. Okay, as can you still recall that? Let's say for example, I ask you to do how do you imagine the structure of an invoice system? So different people may have different imagination. You get me? Okay. So because in the software development we work as a team, so each of the team member must be very clear on what are the things that we are going to create, what kind of system we are going to create. Even though we say our invoice system, however, what kind of invoice system, how the system should look like. Understand? So in this case, we should have a architecture for the system first. So this architecture shows the abstraction of the system. What is the abstraction? Abstraction means less information. Less information does not mean that not sufficient. Be careful. Understand? So it's just sufficient information to shows or convey the message. Okay, on these are the system overall that we are going to create. Understand? Okay, so therefore, come to the first question. Software architecture is high-level design, definitely. Okay, shows in-depth detail of each component. No, understand? Okay, so this is for the detailed design. Consists of different type of structure. Yes, because within a software architecture, we may consist of different type of structure. Some structure may have their different purposes. Maybe let's say for example, in the software architecture, since that it just shows that okay, this system is made up how many components or how many modules, do you think that is sufficient? I don't think it's sufficient because this one is just for the programmer or the developer who know that okay, this system got 5 modules, okay, I'm responsible for this module. But however, okay, you may need to some developer may need to know that okay, when this system is being installed when you complete the program, if the program is going to install, how many server we need, how many firewall we need. Do you understand? Okay, so in this case, we may need to draw another diagram. Maybe that okay, let's say this 5 module. Is it this 5 module is going to install into the same server, or you need to separate out? So you have like another diagram. Am I right? We cannot all combine into one. Understand? So this diagram purposely is also referred as is also part of the software architecture, but it shows that how is the implementation or the installation of the system is. So therefore, okay, we can see that the structure in each of the diagram is different. Okay, so because it's intended for different purpose or intended for different reader. So therefore, it consists of different type of structure. It's a blueprint or abstraction of a system. Yes. Okay. So second question, implication software architecture definition. Okay, I hope that you can refer back to your notes on the software system, software architecture definition. Okay, it's a set of structure inclusive of behavior. Not all good architecture is a good architecture. Okay, each system has an architecture. So in this case, which one is the answer? I think all is the answer. Okay. So number 3, software architecture is important. Why is important? Because it allows discussion on different issues. Let's say for example, the discussion on the quality, okay, the discussion on the separation or dedication of work, okay, in discussion on the how to say the constraint, okay, discussion on the implementation, okay, and then allow the estimation of cost and schedule. Understand? So maybe you can look at the software architecture and say, okay, I have 7 components here. Okay, then you can roughly estimate that okay, how many time or what is the time? Okay, time duration is required for you to complete one of the component or module. Understand? And then what is the cost? When we want to create this module, okay, this module want to have a sensor one, this kind of sensor, okay, where can we purchase? Do we have this sensor or not? Do we have this skill? Understand? Then we can do estimation. So therefore, all is the answer. Process of architecture is a process of software architectural design. Okay, which one is validation? Yes, but this one is not in sequence. Determine the RSA. I don't know what's RSA. Okay, determine the ASR. Yes, architectural significance requirement. Design architecture. Yes, so 1, 3, and 4. Okay. Software architecture need not to include information. Need not include information. The information here is referring to the detailed information. Yes. Is a description of the structure and behavior. Yes. Modern enterprise architecture. This is the enterprise architecture. Yes. Okay. Modern enterprise architecture is concerned on how an enterprise software system support the business process and goal of its enterprise. Yes. It's a description of information flow, personnel, and organizational subunit. Yes, enterprise architecture normally is not necessary to input on the information system. The first one actually is the information system because some of the company they have already established before the system is created. Understand? Okay, so they already have the structure of the organization already. But however, for those organizations which is modern one, modern organization, okay, they may consist of the information system Why? Because they depending on the information to produce their, to perform their operations and to support their organization. Understand? System architecture are very simple. Actually, it's referred to the architecture of the system and their hardware, software, etc. Understand? Okay, it does not involve of the organization. Okay, so it's a mapping of coding. No lah. It's a mapping of functionality and hardware. Functionality onto hardware and software component. Yes. Mapping of software architecture on the hardware architecture. No. It's a concern with a total system including hardware, software, and human. Hey, which one? 2 is correct, 4 is correct. Just now I said 3 is not correct. 3 is correct or not? 3 is correct, yeah, sorry, I make a mistake. Okay. So the output of architectural design or software architecture is what? The architecture diagram, the document, the views. I said the views. Okay, third one is not. What do you mean by views? Remember just now I mentioned that each architecture, you are not going to just create one diagram for architecture. You may create more than one, okay, for different purpose, different audience. This different diagram they provide different view, okay, different meaning in terms of different perspective. So it's called the view, okay. So yes, we are going to discuss this architecture view in chapter 5, okay. So definition of software architecture is one, almost the same one. Which one is the definition of software architecture? Number 1. Okay? Number 1. Okay? Number 1. Number 9, class diagram. Show classes of a system, yes. Show relationship, yes. Show property, yes. Show the foreign key, no. Okay? Use case diagram shows generalization of use case. It's a static diagram. You see, use case is a static diagram. It's a dynamic, right? Use case is it? Use case diagram is it a static diagram or a dynamic diagram or behavioral diagram? Yes. Ryan. Show functional decomposition, no. Create after class diagram is produced, no. 3 and 4 is no. Use case diagram does not show, is not for the purpose of showing functional decomposition. Remember yesterday we discussed, okay, use case diagram is not for the purpose to show. Yes. Oh, like this, then the answer is wrong. Okay, so answer should be, I guess it's number 1 only. Okay, answer is number 1. Okay, yeah. Yes. Okay, so that's it. Yeah. Yes. Who is at you at? Oh, Elias, do Elias.
Jackson Wang.
Jason, no.
Jackson Wang.
Okay, so I see.
Wow, bener, nice.
Wow. Okay, so this is the what? Okay. So that's it, Okay, now we should start what? Almost 1 hour already. We should start our chapter 2. Yeah, chapter 2 is the detailed design. Yeah, because I plan to cover a bit on chapter 4. I'm going to cover chapter 4 first, and then after that we come back to chapter 3. Because actually chapter 3, according to the syllabus, actually is the last session. But however, I feel that if you put this last session, it's not that. I mean the syllabus is not that correct. Okay, so therefore, normally I will start chapter 3 first. But since this is the short sem, and then your midterm is going to held in week 3, okay, then I start chapter 4 and then we come back to chapter 3. Okay? Yeah. And yeah, we come to this chapter, the tool design. Yeah, remember, okay, for the design process, software design process, okay, we start with the architectural design, and then we come to the detail design, and then we come to the construction design and algorithm design, whatever design. Okay, so you can see that, okay, normally we start the design, we start with a very high level. We call that, okay, high level, a bit more detail, and more detail on more specific level of design. So in this case, okay, normally it's called the from top to bottom. I said from top to bottom approaches. So after we have created software architecture, it shows that, okay, let's say for example, how many components or how many modules, okay, that forms the system. So in this case, then we slowly proceed. Okay, maybe let's say for example, I find the group already, okay, this first group do this module, that group do another module, and this group do another module. Then from there, each of the team member, okay, maybe they started to design, okay, the particular component and all the module that assigned to them. So in this case, for each of the component, they are going to identify, okay, for example, what are the interface required? This interface is not the user interface, okay, interface, the interface method, like in your Java, okay, what are the interface required for this component, and then is there any additional classes for this component or not? Okay, how this component works, understand? Okay, how this component works, okay, it's definitely still concerned on the how, okay, so therefore this is the detail design. So you can see that once the high level design is done, means you have the high level of architecture already, then you have a graphical representation of the structure of the software, and then then you should have a document that consists of the high level details. High level details, definitely you can imagine that this so-called high level details actually is not that detailed one. It's still an exception, understand? Okay, but sufficient to describe the high level diagram. So this document consists of what? The module interface or the component interface. Okay, the notes on the possible algorithm or data structure the module can use. Okay, a list of non-functional requirements that may impact the module. Okay, this is the document. Okay, so and then continue. So now you should stop, just as I said, you should proceed to certain component to develop each of the component. Maybe in the component you have a sub-component, maybe in the module you have a sub-module, understand? So therefore, you imagine now we are talking about from high level to detail level, okay, it's top down, understand? Okay, so then we start with the, let's say for example, ordering system. Then maybe you can start with the ordering module first. In the ordering module, okay, what are the classes involved? What kind of interface we will need to put in the order module or order component so that he can integrate, okay, with other components, understand? Then we define the interface, and then we have a look on, okay, what is the constraint, what is the requirement for the interfaces, and then from there, okay, we also go into a bit detail on how this component works, what is the process of this component in order to achieve the purpose or to perform the functions. Okay, and then we can identify, okay, what are the conditions before and after, okay, it is required to be met, okay, when this component is going to perform their works or tasks. Okay, so module one invariant can be specified. This is in terms of we can identify the difference between the module. Okay. And internal data structure and algorithm can be suggested only. Okay, so for this internal data structure and algorithm, okay, maybe it's because you are just start in the detail design, understand? So maybe you can identify, graph out the algorithm and the data structure. But definitely remember, each of the process is an iterative process. We cannot say one shot we can settle already, understand? Okay, we are not Superman, understand? So we plot initial, maybe let's say for example, interface, not user interface, interface, okay, the component interface or the module interface, what is interface method? You know what, okay? It's a functions without implementation one. Can you still recall your Java? Okay. So in this case, okay, we identify the interface because sometimes we need to know that, okay, this component, okay, require what kind of interface, okay, to connect with you. Understand? Okay, so it just determine the structure of the interface. What are the data required? Understand? Okay, we define our kind of interface, how many interface, okay, to instruct, to allow to communicate, to instruct to, or to allow to connect to those functions with inside the internal function inside the component. Understand? We design, okay, so we sketch out and then we design. Then from time to time, we put more information, more details in the to describe the design. Understand? But definitely, how many diagrams you need actually it depends. Understand? So sometimes for a certain module or certain component in the design, okay, maybe you need a lot of diagrams. Understand? Okay. Remember, granularity. Granularity means that different level. Even though in the design, okay, you may have different level of details one. Understand? Okay, you can have just one level of details. You get me? Okay. Why we have a different level of details? Because different level of details provide different information or different number of information. You get me? Okay. So this is the design, and we continue. Now, very important on the first point. Even though this is the detailed design, not over specified. Understand? Not over specified. Don't put too extremely many information to describe it. Understand? Not too over specified for a certain design. Understand? Okay? So let's say for example, we are not going to express a module detailed design using a programming language. Understand? Okay? Programming language is for coding. Okay? It's not for design one. Understand? Okay? So don't until the programming language to show the design. No, not like that. Okay? Nor, okay, we use a natural language to specify a module detailed design. If you use a natural language, let's say English, like writing essay, okay, the problem is, do you think that the developer have the time to digest your essay? I don't think so. Understand? Straightforward, describe, provide necessary, sufficient information, not too less and not too over. Understand? Okay? So, detailed design, as I mentioned, start with the architecture. From the architecture, identify the component, specify on each component or each module. Okay, so then you start the design already. Now, in the design, okay, you have consider the interface, and then you need to consider maybe the classes. What are the extra classes you add inside? Is there additional method or additional property, okay, attribute you need to add into the existing class or not? Understand? Okay, so you need to think of that. And then detailed design also involve of the component design, interface and component. I hope that you understand that interface design is to design the interface that for a certain component so that they can communicate. One of the purpose of the interface design is allow the communication between the component. Or what I mean by allow communication means that let's say I have two components. Component A and component B. Okay. So if I want to call this component to do things, okay, the component must provide certain interface. Am I right? Okay. Because remember encapsulation, right? Encapsulation, an object, okay, encapsulate all the data and function inside. Am I right? It's not allowed for us to directly access to the functions of data. So therefore, we need interface, not user interface. We need interface method. So interface design. Okay. So component design, you need to design the inner part of the component. Understand? Okay. What are the functions? how the function works, how they connect together, and so on. So inclusive of the database design. Okay, especially when you're doing microservices structure, each microservices consists of its own database. So you need to do the database also. But here, you can look at here. Okay, what is described here. You can imagine that almost everything is stuck together one. Understand? But slowly, iteratively, carry and amend and check back and amend one. You get it? Okay. So this is the detail design. You see, this detail design actually will act as a plan for your algorithm or for your code. Understand? This detail design is act as a plan for your coding. Okay? So these are some of the quality that we may need to fulfill during our design. Correctness. Make sure your design will lead into the correct implementation. Okay? And then make sure your design is complete. This complete is very ambiguous one. Understand? Especially for those systems who are always changed and tightly connected to its environment one. Okay? So what do you mean by complete? Then you need to set a criteria. What do you mean by complete? Understand? You cannot have 100% complete one. Understand? Even though you collect requirement, also can collect 100% of the requirement. Understand? Okay? So you need to set a criteria. Just like your what you call your testing am I right? You study software testing this semester.
No.
Yeah. So let's say for example, how do you can say that okay this component and module can be implemented, or maybe you can set a criteria if you pass all the how many percent of the test cases. Understand? Okay, some for example okay. So maybe you can assign that. So therefore completeness is very important, but however cannot do everything one. Okay? So just make sure that you follow what is inside your specification. Even though your specification, some specification you are not able to fulfill. Am I right? Okay? Then you need to consider or evaluate again. Understand? Okay? And then make sure your design is changeable. Changeable means that you need to design your system in a way that it is allowed change, easy to change one. It's maintainable one, it's changeable one. Understand? Okay? If your design cannot be changed, it's how to say cannot evolve, okay, then it's very difficult because changes you cannot ignore. Even though your requirement also change, if your requirement change, your design change. Sometimes when you do your design, you see that in design, there is a conflict. If you follow the requirement, then you need to go back to the requirement and change again, and then come back to the design and change again. Understand? Okay? Always be ready for changes. Efficiency, make sure it does not waste resources. Make sure it does not waste resources. Simplicity, keep your design as simple as possible. I understand that design sometimes is never very difficult to make it simple, but just try your best, okay? Clear and easy to understand, okay? We come to the software design process. This one is the introduction. Design is more on how we are going to achieve the requirement, based on the specification. So, this design process, okay, then these are the steps involved. Look at them. 1, 2, 3, 4, is it 4 steps? 4 steps, okay. So, a solution design is created from the requirement or from the previous use system. If from the previous use system means that you will reuse the previous system item. Understand? You reuse, okay. Reuse means that not only requirement can be reused, you can reuse the design, you can reuse the code, you can reuse the hardware, software also. Understand? Okay. So you have a solution design is created, and then all the objects are identified and grouped. This is more to the object-oriented design. Okay, so task hierarchy is achieved and defined, and then the framework of your application is defined also. So after this design, what is the output? Is your SDD, software design document, or system design document. Okay, so this system design document is those documents that consist and describe the design of the system. Okay, now there are many different standards that specify the format, the structure of this document, this SDD. As I said, we have EEE, we have ISO. Okay, so for your homework, okay, you can Google, okay, different maybe template or different standard of SDD. Understand? Okay, so if because not every time you need to follow IEEE standard or ISO standard, it depends on the company. Understand? So maybe your company have their own standard or own practices on how the structure of this document is, then you need to follow the company's practices lah. Understand? Okay. This is the software design process depicted by this diagram. As you can see that the first one definitely is the architectural design or your software architecture. Okay, so your software architecture based on the requirement specification. Okay, then you have your software architecture, and then this is the abstract specification. Abstract means not in that specification or not too specific. Okay, maybe it's just an overall specification. And then from here, architectural design, what is your output is your system architecture. Okay, system architecture, then you can derive also the abstract specification. Understand? So from here, then you are being more detailed into your software specification. Remember your requirement, you have main requirement and sub requirement also. Am I right? You have one requirement, and then under this requirement, you have sub requirement also. Okay, more detailed one. Then based on this specification, then you have your interface design to derive, okay, all this to identify or to define all these interface specifications. Okay, and then from there you may have your component design to describe your component. Okay, and then for your data structure and algorithm. Okay, actually this is just a generic generic process of your software design. Understand? Okay, in general lah. Okay, but however, it's not necessary you need to follow this one finish, then you come to this one finish, you come to this one finish, you come to this one. Not like that one. Understand? Okay, because certain part of the design or certain part of the design you can write in parallel one. Okay, but this diagram just to show the general idea or concept of this software design process. Okay, or maybe after your architectural design here, okay, maybe you want to use a different type of methodology. Okay, you separate. Okay, so component A, B, C, D. Okay, then each component may need to go through this one. Okay, so therefore you can see that is how are you going to manage the process of it. You get me? And also depending on your methodology. This is the description of the process on the diagram there. Okay, architectural design shows the subsystem of the that made up of the system and relationship between them. Okay, abstract specification describe the subsystem. Describe the subsystem. Understand? Okay. Interface design. This one you need to document and describe the interface for each of the subsystem. Understand? For each of the component now. Okay. And component design here, then you go into the component design and then to describe the component. Okay. Data structure. What is data structure? Class? Can you give me an example of data structure? List, queue, stack, array, record, okay, all is the data structure, alright? So from there, you can start to design a data structure. Then from a data structure, then maybe at the same time, you can start to do your algorithm design. Algorithm design actually is to define the step, okay, to achieve outcomes. Okay, you can use flowchart, you can use activity diagram, you can even use pseudocode. Okay. Software process model. This one I'm not going to cover this one. I don't know why this slide come out. This one has already been covered in your software engineering, the first subject, like waterfall, agile, what SDM, spiral model, all these things. This is called the process model. Okay, so we have a generic model, we have iterative model. Okay, so let's say only generic model actually is a waterfall, like one stage after another. Okay, the other stage cannot finish unless that the previous stage is completed. So iterative now, like the agile, okay, it's definitely iterative. Okay, so this is the process model. Don't worry, this one will come up. Just to revise the previous chapter only, previous subject only. Okay, so design approaches. Now, in the design approaches, okay, if you ask me, because this slide actually is follow certain authors or reference book. Okay, in that reference book, they say as a design approaches. When you go to Google software design approaches, they may come out different approach one, not like these two. Okay, but however, we've just stick to one author, stick to this reference book. Okay, the design approaches here introduced is a top down or bottom up. Okay, top down is, as I said, we start with the higher level and then we go to detail of each of the component design. So top down, okay, until the algorithm and the, okay, which lead us to the coding. So therefore, this top-down approach actually is suitable for us to develop a new system from scratch. Understand? If we are going to develop a system, okay, maybe we are going to develop a system from the existing system, understand? Okay, from the existing system, then we may consider to apply bottom-up. Bottom-up is different. Bottom-up approach, bottom-up approach or bottom-up design, okay, is we design the lower level first. We start with a specific function first, understand? Okay, and then we move forward to the high level, and then we move forward to a high level. Understand? Okay, so this is the bottom-up design. So therefore, bottom-up design can be used when we try to build a system based on another system. Okay, based on another system. Understand? Okay. So, but however, for bottom-up design, there is a problem. Why? Bottom-up design, we cannot see the overall structure of the system. Understand? Until we produce the highest level of the system. But however, for top-down, we start with the high level, then we can see the entire overall picture of the system. You get me? Okay? Now, this one, very easy. Very easy. For this one, let us have a look on the principle of design. The principle of design is not only for this one. Okay? Not only for this one. Okay, so there are many principles, but in this, we just cover this principle. Okay, or concept. Abstraction. What is abstraction? Summary, information, right? Isn't it? Like architecture is an abstraction. Okay. In this means that principle means that remember the word granularity. Okay, different level. So in different level of design, we need to provide sufficient information. Understand? Sufficient. I use the word sufficient, not too small, too abstract or too detailed. Understand? Depend on the level. You get me? Each different level of design may provide different level of abstraction. Understand? Definitely higher level of design, you may have higher abstraction. Lower level of design may have lower level of abstraction. Lower level of abstraction means less summarized, means more detailed. You get me? Okay? So different level, then you need to provide sufficient information, okay, to support those specific level of design. Understand? Okay? Decomposition and modularization, we try to break our system into different independent component or independent module. Why we want to do like that? Why? One is easy maintainability. Understand? Okay, and then is how to say easy maintainability and easy to handle. Okay, so and then for the encapsulation, just now we said that actually this is the object-oriented concept. Encapsulation is one component we try to hide the data, okay, and their method within the component, understand? Or the object that we call, okay. So therefore, when we want to access the component, we need to provide the interface. You get me? Okay? You get me? Okay? So coupling and cohesion. What is coupling? What is cohesion? Coupling means that the dependency. Understand? Dependency and cohesion is how those functions within a module or how those modules within a component works together to achieve a task. Okay? Normally we encourage low coupling and high cohesion. Separation of interface and implementation, yes, this is more on the, can be related to the concept of polymorphism. Still remember polymorphism? What is polymorphism? Yes, Emma, what is polymorphism? Polymorphism is
one method or different
same functioning but different number of parameter or even data type perform different kind of function.
Polymorphism actually is polymorphism. Okay, polymorphism refer to same function name but different implementation. Get me? Okay, same functions, same method, different implementation. Do you get me? Okay. So let's say for example, open door. Okay, there are many ways to open the door, right? Isn't it? Pull in, pull out, pull down, pull left side, pull right side. Am I right? Okay. Same function but different implementation. Okay. Or same method, different way of implementation. Okay. So sufficient and completeness, yeah, you need to make sure your design is sufficient and complete. Provide sufficient description, okay, and able to fulfill all those specifications. And separation of concern. This one, concern actually is those areas when you design of your system that will affect the stakeholder one. Let's say for example, your security, okay. So concern we are going to discuss in chapter 4. Okay. Now, continue. Now, abstraction. Okay. This is a Wikipedia. Wikipedia means a lot of text here. Okay. So normally I'm not going to read through all the text. Okay. So now we come back again as a revision. This is not what you see. Okay. So you can see that different level of abstraction means that provide different level, different number of amount of information, okay, to describe the design. Let's say for example, architecture level, okay, just help to the identification of software component and their interface content. Understand? Okay? For detail phase, identify the entities, functions, and interfaces required to realize the component. So you can imagine that for this one, the abstraction will be lower than this one. I mean the information. Understand? Okay? So construction level means that more further detail in detail compared to this one. You get it? Okay? So this is the what I mean by abstraction. Decomposition and modularization, as just now we came across, separate your system into different module or component. Each component perform specific or related same function. Understand? Okay? So, and then encapsulation, information hiding, hide all the data, okay, and the internal details, okay, of a certain component from outside entity. Understand? If the outside entity wants him to do something, he needs to go through the interface. Okay? So coupling and cohesion. Why we need to have encapsulation? One thing is to avoid any security issue. Understand? Okay? To avoid any directly change on the data of a certain internal data of a component. Understand? Okay? And also to try to avoid any high coupling. Understand? Okay, if you allow direct setting, and then every time everything can, an external entity can access on the particular data or function, then you indirectly you create more coupling. Understand?